Hey everyone, so this video will give you a quick introduction of just the general idea of what we use confidence intervals for and kind of general steps before we get into the actual statistical process for it. So we'll start with that and then we'll get a couple of examples in. So I always start this chapter just kind of talking about and giving this example on, let's say you wanted to make a weekly budget for groceries, okay, or yes, this one's going to be for groceries. So you're trying to estimate your weekly grocery spending for the future. Okay, so how would you go about doing this? So you're trying to really make a budget for months in the future. So what kinds of things factor into, how much money you're going to put aside and how much money you're going to plan for? So obviously we know, different times of year, things like that can be different. But the general idea when you're trying to estimate something, so the general kind of process here would be you would first really start with past months. Well, I'm sorry, this one's weeks, so we'll start with past grocery spending. I'm sorry that my handwriting seems to be even getting worse on this video. Let me do that again. Start with past weeks, right? You want to get an idea from the past how much you spent. So ideally, think about what you did last week. Ideally, how many weeks would you go back? Well, ideally, you would have greater than or equal to 30. Okay, so a lot of times people say, well, you would want 52 weeks, so you would have a whole past year and see the fluctuation in different times of the year. But at least we would want 30. Why is that? Because we want to be able to use the normal distribution. Okay, and last week you learned that if you have a sample size of at least 30, you can use the normal distribution. So that's the idea. We'd first figure out, okay, what is the average I spent in the last 30 weeks? So that gives us a good estimate. That's what we call our point estimate. That's our starting estimate. We know we're not going to be 100% accurate, though. So we still need to kind of add or subtract. And when I'm teaching this in class, I call this kind of some wiggle room, right? You're not going to be 100% sure. You don't want to go to the grocery store with the exact amount that your average was because, you have to have a little give or take. So that wiggle room is kind of your give or take. So if you kind of picture it, you say, okay, in the middle you've got whatever you spent before. The average from the past. And then you take that average and you add some little wiggle room, okay, to get the top value. And then you subtract that little wiggle room. Okay, so this is what we're eventually going to call our error. But the idea is our best estimate is what's happened in the past, and then we add or subtract this little cushion on each side so that we go to the grocery store with not exactly, the amount that we had in the past. Okay, so let's start with an example now. That's just a kind of the general process, but that's the main idea. We need to figure out what's the average, and then the harder part now is, well, how much wiggle room do I leave? How much error do I add or subtract? And that really depends on how confident I want to be that I have the right amount of money. Okay, if I want to be more confident, let's say I wanted to be 98% sure that my grocery spending is in the region that I make, well, then I have to have a big region, okay? If I want to be, say, 80% confident, my error might be a little bit smaller, so we have to kind of find a balance between that. Okay, here, so let's say this one I'm giving you a set of data, okay? So this data represents the time spent in minutes for one class worth of how long they spent on Facebook. So I had gotten this from an actual class that I taught one semester. So I had this was 33 values. Okay, so let me just jot a couple things down. N was 33 for this class. This is just one sample, okay? We're going to try to construct a confidence interval for the average amount of time for all STAT students. So I'm using a sample of 33 to make a prediction about how much time do all STAT students spend on Facebook. And that's what a confidence interval is doing. It's using a sample to predict something about a whole population. Okay? So the very first thing I need is to figure out, okay, well, on average, how long does this class spend on Facebook? So that's why I have over here this X bar. So you will put this into a list, into the calculator, okay, because you don't want to do that standard deviation by hand. Put it into a list. I already did that. And I have the X bar to be 48.4. So that's my best guess so far. I'm going to guess that all my stats students spend 48.4, all stats, not just this one class, but all of them, spend about 48.4 minutes on Facebook. Okay, but I can't be so sure that that's going to be exactly the case, so I'm going to figure out some wiggle room, some error in a minute. The standard deviation of this one, it's a sample, so my sample standard deviation from the calculator is 58.4. So that one I wouldn't want you to do by hand, because at this point, the main part of this problem is making the confidence interval, not being able to do a standard deviation by hand. So far, this is what I know. I know that my confidence interval is going to look like this. It's going to be 48.4 in the center. You don't have to show your work like this. I just kind of like it as a visual. I am going to add some error. Oops. And I'm going to subtract some error. So I already am starting to build. Just what that means, I'm starting to build my region. It's just a matter of what's my error going to be. So if you look in, so the error formula, how you figure out the error, it looks like this. Let me just draw a little line down here. Okay, I'm going to kind of break this into 3 parts. The first part being all my values. A lot of times this is given to you in the problem. I gave you the data instead. So here's the stuff that I'm going to need. What else I'm going to need is this. Okay, so C, my confidence level is 0.9. Okay, because it's 90%. So this is what this means. It means if I were to draw the normal curve, okay, I am using the normal curve because my sample size is big enough. Later on in the chapter, you'll use a different distribution if n is not big enough. So a confidence interval of 0.9 looks like this. Okay, 90% of the area in the middle. Okay, so I'm going to come back to that actually in 1 second. So my error formula is actually very basic. It's the critical value. So it's the z value that is associated with that 0.90 times standard deviation, which I have, and over square root of n, which I have. So the only thing I don't know right now is this. Okay, and that's why I drew that normal curve. Now you're going to find this is a very common confidence interval, so you're going to see this one on the normal table. They show it down the bottom what the critical value is for this, but I really want you to know how to find it, so if it's an uncommon one, you can do it. So it uses everything we did back in chapter 5. So if I have 90% of the area in the middle of the graph, that means over here is 0.05 of the graph, and over here. Okay, because that's how it would make up 100%, the 10% cut in half. So I go on the calculator and I do inverse norm 0.05. And I find the critical value attached to that area is, the lower one, it's really, if I did the lower one, which I'm putting in 0.05, it's negative 1.645, okay? So the idea is that it's really plus or minus 1.645, okay? Because if I did the top one over here, I would have gotten the positive 1.645. So when I put that into a formula, when I come back over here to my error formula, I'm just going to put the 1.645, okay? And I'll show you why in a second. Let me put everything else in here. Let me use parentheses now. 50.4 over square root of 33. Okay, so my error, I already calculated this before. My error comes out to be 16.7. Okay, and the reason I dropped the plus or minus is because when I do my third little column over here, it's creating my actual interval. So my 48.4 is in the center, and I'm going to add and subtract my error. That's my wiggle room. Okay, that's kind of my cushion so I can be confident. So that's where the plus or minus comes in. So you don't really need to put it into the error formula. So let me write one quick sentence down here so you can see what this means. So let me box that off. Okay, so the idea now is to really understand what we just found. So it means that we can say with 90% confidence that all stat students, not just this class, we already knew what this class did, but we're making a prediction about all, that all stat students spend between, and I already found the values. When you subtract the error, you get 31.7, and when you add the error on, you get 65.1. Okay, so we can say with 90% confidence that all STAT students spend between 31.7 and 65.1 minutes on Facebook. Okay, that's what we actually found. So my next slide here, we probably won't get through this entire example, but I just want to show you one quick difference. Okay, it's the same actual data, but I'm telling you here to do a 96% confidence intervals. So everything else is the same. I don't want to make this video too long because then it's very hard to post, but I just want to show you one thing. Okay, the only difference, this would all be the same, n was still 33, is that if I have a 96%, okay, that means that it's bigger in here. Okay, so now let's see, this would have 0.02 in it, and this would have 0.02. So I'm just trying to find my critical value. So if I do inverse norm 0.02, I'll find my critical value to be, it's plus or minus, but it will drop it when I use the formula, 2.05. Because if I want to be more confident that I get the right interval for my mean, then I have a bigger error. So when I go and do my error now, it's going to be 2.05 times this 58.4 divided by square root of 33. So I'm going to get a bigger error. My error is going to end up being, for this one, 20.8, which means I'm going to add or subtract 20.8 minutes. This is still minutes onto my mean. Okay, so changing the confidence interval makes my critical value for my z critical bigger or smaller depending on which way I go, and that's how it affects the error. Okay, so for after this point, you would just do your 48.4 plus or minus 20.8, and you would build your interval, and then you would always want to be able to interpret it the same way we did that last one. Okay, so hopefully that helps. Both of these were for large samples, and like I said before, later on in the week you'll look at how to do this for small samples, but same process. Okay, have a good week.